Last time I talked about a number of things and got up to the point of beginning to discuss the problems that exist with the concept merge that was developed back in the 90s and has been used in many ways since. There's a kind of a simplest version of merge, which was the original intention, which just had the two special cases, external and internal merge. As I mentioned last time, the more primitive of the two is actually internal merge, but because of the fact that language has exocentric constructions, that can't suffice. I mentioned some of the things that you can explain on the basis of merge, and also wanted to make the point that a genuine explanation in linguistics will, if we're viewing the study of language as part of the study of nature, basically the biolinguistics program, which I think has roots back to the 17th century, as I mentioned last time, although you have to skip the structuralist, behavioralist period. If we're engaged in that enterprise, then a genuine explanation will always have to meet these austere conditions of learnability and evolvability, which are very hard to meet anywhere in biology, and in particular here. There's some reason to think that the conditions might be attainable here because of the specific conditions of human evolution, which I mentioned briefly last time. If that picture is correct, there's some antecedent reason to believe that there might be success in the enterprise, which is rare in the biological sciences. Well, the concept merge does happen to meet those conditions. It meets the conditions of learnability because there's nothing to learn. It meets the condition of evolvability because since, in fact, the basic problem, the basic principle does exist, there had to be something to evolve the computational procedures that yielded it, and it would obviously be at least the simplest one. So we can be secure with explanations based on the concept merge, but anything else is problematic. It's a very austere condition, but it's one that really has to be met. Well, I then started in on, talked about some of the examples where you can get an explanation, some interesting cases, but there are problems. The problems are that the concept was very loosely defined, and all sorts of other applications, implementations have been given, which kind of more or less fall within the original loose definitions, but I think are probably illegitimate. I'll talk about that today, and I think if we think through the matter carefully, we end up with just allowing what was originally intended and none of the extensions for good reasons, which leaves us with many problems, some of which have, I think, potential solutions. Others look quite mysterious. Well, I mentioned last time something which is a kind of a paradigm for many cases. The simplest case, when you have only two elements. And first of all, since we do have exocentric constructions, it's going to be necessary for the operation merge to actually operate on a workspace, not on elements, because you're always changing the workspace every time you apply merge. So we have some sort of a definition that we call it capital merge, which says take two things that you want to merge and a workspace that exists and form a new workspace, which will include at least this and then other things. We don't know what. We have to ask about that. And I suggested a notation which I sometimes will forget. Sam fixed it last time. I will use square brackets for the workspace and curly brackets for the syntactic objects. There's a crucial difference between them. The workspace is a set, but it's not an accessible object for operations. So we'll just distinguish them by that notation. And the notation actually means something. So for example, suppose the workspace consists of just X, we want to distinguish that from X. So the singleton set is different from its member because the workspace is not a syntactic object and X is. On the other hand, for the syntactic objects, we want the opposite convention, namely that the singleton set is the individual element. And there are good empirical reasons for this, which go back to phrase structure grammar. So in phrase structure grammar, you just, by convention, didn't allow rules like, say, NP, arrow NP, or V, arrow V. That's assumed not to be a reasonable rule. That's essentially saying that a singleton set is identical with its member. Now, this was fudged often in the use of phrase structure grammar. So there were rules were allowed like this, or when you move from phrase structure grammar, which is totally unacceptable for language for myriad reasons, as was recognized since the 50s. When you move from that to X-bar theory, then this becomes meaningless, right? Because there's no VP if it's only V. Actually, despite the fact that it's meaningless, it is used. So for example, if you try to implement Ritchie Kane's LCA, try to get it to work, you're forced to have rules like this, which is a serious problem in the LCA system, I think. You have to show that, you have to argue that if you have a verb-object structure, the object, even if it's a pronoun, still is complex. Otherwise, you don't get the right ordering. But that's technically illegitimate in an X-bar theoretic structure, and here the analog of that illegitimacy is this convention. So we want to accept this convention, which has a number of consequences for syntactic objects, and this convention for workspaces, which are different kinds of things, though they're all sets. Okay. Well, in the simplest case, we just have a workspace consisting of these two guys, and we merge them. AB gives us a workspace which contains the set AB, which we've merged, and the question is, what else? Okay. Now, if it was normal recursion, like, say, proof-theoretic recursion, you would have here A and B, but you can't have it for language for reasons which I mentioned last time. And this is a kind of a paradigm that applies to a great many cases of the extensions of merge. The reason it doesn't work is that this can be built up to an object of arbitrary complexity. This, since it's accessible, can then merge to it. That gives you a relation between the thing that's merged up here and the thing down here, which violates every imaginable condition on movement. So that's illegitimate. And we do not want to have legitimate operations which yield illegitimate conclusions. That's elementary. So therefore, we conclude that, surprisingly, if these things aren't here for language, recursion for language is different from general recursion. Namely, it has the property that I told last time, restricting resources. And it's what computation for language and presumably for organisms generally is doing is trying to keep the resources as limited as possible. You have to get something new, or you don't generate anything, but you want to generate as few things as possible. This really turns into a number of subcases. One subcase is limiting accessibility. So accessibility means something's accessible if the merge operation can see it and do something to it. We want to limit accessibility. If we allowed general recursion, we'd have too much accessibility here. So we want to limit it to the minimal amount. It's tempting, as I mentioned last time, to try to relate this to a more general property of brain computation. Namely, the brain is pretty dumb and slow. So what it does is throw out tons of data that are coming in. In fact, that's its main activity, is to get rid of lots of stuff that's coming in. So in the visual system, the sensory part of the visual system is essentially perfect. So you get a cell responding to a photon of light. Can't do better than that. But that's pouring into the brain tons of information that are going to totally overwhelm computation. So the sensory system throws out almost everything. You get down to just the limited part. The same true in language acquisition. The phonetic system is throwing out just about all the noise that comes in and picking only very limited kinds of phonetic properties, and even those are being thrown out very quickly in early language acquisition. In fact, that's the main part of language acquisition. Charles Yang's model for general language acquisition kind of exploits this generally. Notice, incidentally, speaking of Yang, that if you have this property, you infer determinacy. It turns out that if you think it through, when you limit the resources available, you're also going to force determinacy, meaning the operation will be uniquely determined by what it's looking at. That's not a trivial property. It wasn't true, for example, of standard versions of phrase structure grammar. So in a phrase structure grammar, if you reached a point where you had something of the form NP, v NP, and you have a rule expanding NP, which one you apply it to is indeterminate. It's a normal part of phrase structure grammar. But if you have, in this much narrower system, resource restriction, you get determinacy. And that's kind of important because Charles's work on price of productivity, or what it's called, very important work, I think. That work depends crucially on the assumption that the operations are determinate. So if you want to get those rich consequences, we want that property. It's one of the few examples I know of work in computational linguistics that has real consequences, very rich consequences, very important work. So resource restriction makes sense as a property, has a lot of interesting consequences. Lots follow from it. Now, resource restriction is going to have two components, sort of. One of them is restrict computation. The other is restrict resources. Restrict computation means limit yourself to the minimal kinds of computation that are possible. Well, merge is one case. It's the least possible computational operation, but it also wants to operate in the most limited way. So one of the consequences would be keep to minimal search. Don't use deep search if minimal search already works. many empirical consequences to that. Notice that limit accessibility already includes things like PIC. The phase impenetrability condition is one general condition that limits accessibility. Minimal search is another. It means, for example, in successive cyclic movement, when you move to the next stage, you don't look down. You only find the top thing the first thing that you find. That raises many interesting questions about possible ambiguity. Are there ambiguous cases? I'll come back to that quite interesting question later on. But those are the things that are in the background. Now, if you look at the original definition of merge back in 1995, it actually had this property inadvertently. It wasn't noticed particularly, but the operation of merge as it was defined basically as replace, which says don't keep what you already had, but get rid of it. That was not particularly noticed, but it's a property of the original definition. And there are good reasons for it. We can now see good reasons for it. If you don't accept it, you do get legitimate operations which yield illegitimate conclusions, the clearest sign that something's radically wrong. And this is a paradigm case, but it extends to many others. I'll go into that. Well, so for example, take something that I presume no one's ever proposed. I'll draw trees, but I should make it clear that trees are very misleading notations. One should beware of them. For one thing, a tree notation suggests that this exists, that the root exists. But why does the root exist if you just have merge operations? In fact, what the root is understood to be is something that comes from some other source, namely projectability. But that should be a completely separate property. Projection seems to have nothing to do with the compositional operations. The tree notation kind of sticks them all together and misses many questions about what projectability is. A particularly interesting case in exocentric constructions. So what's projected? That has interesting consequences. The whole theory of labeling deals with that. I assume you're familiar with it, or I'll put it aside. But we don't want that. The other thing that tree notations allow you to do is draw lines in all kind of complicated ways. So you can draw a line from here to here, and that seems to mean something in a tree, but it means absolutely nothing in a merge-based system. And you really have to be very careful about that. So I'll use trees for exposition, but with the condition that you don't take them seriously. Well, let's take something that I presume nobody's ever suggested. Suppose you have a structure like this and you decide to merge these two guys. Okay. The original definition doesn't say you can't. That would mean you're forming the set XP, YP, but it has nothing to do with this original set. It's just something added on. And notice that it has exactly the properties that are barred here. It adds accessibility. Okay? It's adding new accessible items, which will then be subject to exactly the problem I already mentioned. Namely, this object can be made as complex as you like. You could then merge one of these guys to it, and you violate all conditions. So we're not allowed to do this. As far as I know, nobody ever proposed this, but there's a good reason why you can't do it. However, there are things that people have proposed, and I think they're all ruled out for the same reason. I'll kind of leave it to you as an exercise to work out why. But if you think about things like parallel merge, which is usually written in trees like this. Again, a case where the tree notation seems to be saying something, but it's not, because there's no way to construct this. But if you think about what parallel merge is doing, it's increasing accessibility, runs into this very same problem. Parallel merge is the basis for a lot of work in the literature, which yields multidimensionality. The idea of multidimensionality goes back to the 70s, work by Jim Macaulay and others. But if you try to reconstruct it in a merge-based system, you can draw the trees with funny lines like this. But and the way of constructing it is through parallel merge, which has this lethal property that it yields illegitimate consequences from legitimate operations. So everything that, if you look up the handbooks of contemporary syntax, there's a chapter on multidimensionality, which has many interesting consequences about 8dB, cross-the-board movement, parasitic gaps, and so on. But none of them work, because they're all based on an illegitimate operation, which has this deficiency. Same true of sidewards merge, has the same problem. The same is true in spades this time of late merge, which is widely used. I've used it a number of times, many others have. Late merge, first of all, has this problem. It's creating a new, when you draw a tree, it looks as if you can do it. You just add a line to the tree and you've got late merge. But if you try to spell it out in terms of the merge operation, you're first creating a new object, which is bad enough because that's already illegitimate. But then you're adding a new operation, a substitution operation, which inserts what you've just created at just the right point inside the tree. That's a pretty tricky operation. Try to formulate it. It's a new complex operation. So late merge has a double problem. One, the problem of not restricting accessibility. Second, the problem of invoking a new operation, which is really unformulable. It's quite a complex operation if you think about it, and it's way out of the framework of anything we're talking about. So and there's many very interesting results that follow from late merge, very much like multidimensionality. But I think the way to look at those results is as problems, problems that have been constructed in an interesting way. So we have organized data instead of chaotic data, which is a step forward, but it's only a step towards eventual explanation in terms of something that meets the austere conditions that we're interested in. And that sets interesting empirical problems to address. I think there are some answers in some cases, which I'll... Okay.
Limited accessibility.
Somebody, yeah, that's right. Can you figure out what's going on? Let there be light. Okay. Is that the second day of creation, I think? Thanks. You're divine. Okay, so where are we? Sorry. We need a different God. Okay? You guys doing that? Okay. Well, there's a lot that follows from all of this. I'm kind of leaving it as an exercise to think it through. But if you think it through, what you'll find is that all of these applications, extensions of merge, including the kind that nobody's ever thought of, including others that have been used widely, all have the same problem. They all have exactly the problem that you see with the simplest case. And the problem, again, crucially, is that they are constructing what are alleged to be legitimate operations, but when you apply them, you get illegitimate conclusions. And that is the sign that there's something seriously wrong. Obviously that can't be. So all of those, the entire literature, big literature, that yields very interesting array of results is not legitimate explanation. It's a proposal of problems. It's posing problems that are interesting, important, big step forward. It's useful to have organization of data instead of just chaotic data, but that's not explanation. That's not the goal of linguistics, at least as a science. Well, all of this suggests a kind of a research program. First, determine which subclass of the loosely characterized operations of merge, which subclass of them are in fact legitimate. That's a research problem. If you run through it, I think through it case by case, again, leave this as an exercise, I think what you end up finding is the originally intended ones, not defined properly, but the originally intended ones are probably the only ones. The rest of the extensions are not legitimate. Interesting consequences, but not legitimate. The next problem is to formulate merge so it gives you just the right ones, and then try to explain why that definition of merge is the kind that should be reached on general considerations, general conditions that any linguistic operation ought to meet, and this should be deducible from them along with third factor properties, minimal computation, minimal resources. Well, I won't run through the cases, but we get something that looks like this. And we have to put various conditions on x1 to xn. So what are the conditions? Well, I won't bother spelling it out formally. I'll just say it intuitively. Don't lose anything in WS. Spell it out. It means if Y is in WS and Y is distinct from P and Q, it's got to be in the X's. Okay? So you don't lose anything. We don't want something to just disappear in the course of the operation. Second condition, limit accessibility. In fact, limit it to 1. It has to be at least 1 because you're constructing a new object. Okay, otherwise you're not doing anything. But don't do anything beyond that. So no new accessibility should be permitted by merge. And a third condition is x1, xn should be minimal. In other words, don't throw in some new junk that has nothing to do with the operation. Well, what we want to do, of course, is get rid of these. We want a definition of merge which has no conditions. But notice we basically already have that. The first one, that follows from the no tampering condition. The no tampering condition has to be revised now so that it doesn't apply to syntactic objects, but to the workspace, because all the operations are on the workspace. The no tampering condition says if something's in the workspace, don't change it, okay? Well, the most extreme form of changing is to delete it. So you can't delete it. So from any reasonable interpretation of the general condition, NTC, which is part of the strong minimalist thesis, it follows you're not going to lose anything. This one we've gotten rid of. It follows from resource restriction, which is a special, crucial property of organic computation, it seems, at least for language, but probably quite generally, probably related to the general brain activity of massively reducing the data available for computation. So we've gotten rid of this one, but this one implies this one. If you don't add, if you're going to add any more junk, it'll increase accessibility automatically. So therefore, we don't need that condition. So therefore, we can get rid of all of these. They all follow from plausible, in fact, necessary conditions on general computational procedures for an organic object. So that gives us the best possible definition of merge. And if you think it through on principled grounds, and if you think it through, it restricts it just to the original intention, which was never captured by the actual formulations, just kind of in mind. Turns out that what was in mind was actually created, correct, and all of the extensions have to be barred. Now, I should say one word about one of the general conditions, kind of a meta condition, descriptive adequacy. I've just been assuming that we want them. We want the operations, of course, to be descriptively adequate, but that's not an innocent notion. You don't know from data whether they're the right data. Descriptive adequacy, and this is not just linguistics, all through rational inquiry, all through science, is a theory-determined notion. It's not innocent. You get a lot of data in, say, chemistry. You don't know, is this real data or not? There are two kinds of problems the data could have. One, it might involve too many variables, lots of other factors that you're not interested in. In fact, if you just look at the phenomena of the world, they're just worthless, you know. Too many things are going on. So you don't develop physics on the basis of just observation of the phenomena in the world. If you're in Silicon Valley, that's the way you do it. But I'm talking about science now, not Silicon Valley. So what you do is try to find, get rid of the data that doesn't really matter. It doesn't have to do with what you're interested in. But that's a theory, internal notion. The other problem is that you look at the phenomena that are around you, they usually don't include the relevant data. They don't include the critical experiments, the kind that matter. These are all problems that were faced in the early days of the scientific revolution. And they were sort of settled for the sciences, but linguistics and the soft sciences haven't really internalized it. So if you go back to, say, the 17th century, the Galilean effort to try to rebuild science on firm grounds, throwing out neo-scholastic occult properties and so on. What was important, and he had a hard time convincing the funders, the aristocrats, not the National Science Foundation, convincing the funders that there was some point in this. So it was very hard for the aristocrats to see why you should care about whether what happens when a ball rolls down a frictionless plane, which can't happen. Why should you care about that and not leaves blowing around in the wind? You know, which you see all the time. That's a big move, actually. And if you think about the problem, it's not trivial. So why is the rate of fall independent of mass? I mean, if Galileo had done experiments, they wouldn't have worked. Too many other things would have happened. So what he did was just a thought experiment, neat thought experiment. He said, suppose you have two masses which are identical, two objects which are absolutely identical, okay? And suppose they fall. Well, obviously they'll fall at the same rate. Suppose you bring them a little bit closer together. Well, that's not going to make any difference. So they'll still fall at the same rate. Suppose you bring them so close together that they actually touch in a point. Well, that can't change anything. But now it has double the mass, okay? So we've proved the theorem without an experiment. Most of Galileo's experiments, if you run through the dialogue and so on, are really like this. So for example, another problem that was bothersome is what happens if you have a sailboat sailing through the ocean and you drop something from here. Where is it going to fall? Is it going to fall here or is it going to fall here? Aristotelian physics says it'll fall here. The sailboat's moving forward, so of course it'll fall behind where you dropped it from. Galileo wanted to argue that it's going to fall here because the mass is getting accelerated with the sailboat. Suppose he had done experiments. I leave it to your imagination to see what you would find about where the thing is falling. You get junk, okay? So you don't do experiments, you just do critical experiments, often just thought experiments. And for linguistics, that happens all the time. So you read the literature these days, linguistic papers, cognitive science papers, stuff coming out of Silicon Valley, Google. One of the great achievements heralded is to be able to parse 95% of the sentences that you find in the Wall Street Journal, okay? Suppose you could parse 100% of the sentences and get the right result with training. It would mean absolutely nothing. A sentence in the Wall Street Journal is just an experiment. Is this an acceptable sentence or not? You don't care if you can match 100% of random experiments. That's of no interest. First of all, a lot of the experiments have the wrong data, too many variables. Also, the other thing is they don't include the critical experiments, the kind you're interested in. Can you get parasitic gaps, for example? Can you get garden path sentences? Well, it turns out when you look at the critical experiments, they fail almost totally. They get maybe 95% of the data, but that's a result of absolutely no interest. And a lot of the field is sort of going off in that direction. Even in the linguistic literature, you find it. Anyhow, without going on, this concept is not a trivial concept. It's not an innocent concept. A lot depends, a lot follows from trying to understand what descriptive adequacy means as a theory internal notion. Anyway, we certainly want to we want to be able to achieve the level of understanding that was reached in the 17th century in the sciences. I think that's a fair goal to try to achieve, to understand that there's something significant and serious and theory internal about what we call descriptive adequacy. There are other conditions that have to be satisfied. One of them, most of them we just take for granted, but one of them, call it stability. By that I mean, in the course of a derivation, a syntactic object can't change its interpretation. Okay, so for example, if you topicalize, say, Mary's book, I want to read, in the internal system, the non-externalized system, it's going to be Mary's book. But these two objects have to have the same interpretation. Like this one, you can't be saying, I want to read the book that Mary owns, but I'm talking about the book that she bought, let's say. Okay, that's sort of taken for granted. Same for ellipsis. If you say, I read Mary's book and so did Bill, what Bill read is the same Mary, and if she owned it, it's ownership in both cases. So you have to have a general principle that's telling you that anywhere through a derivation, you can't change the interpretation of the expression. It doesn't matter for right now how you express this fact, but it's got to be somewhere in the deep inside the theory. And that has a lot of consequences. We'll come back to that. At this point, notice at this point, we're getting into a very interesting area, the area where we have to identify what are called copies and repetitions. Okay. So here, the two cases of Mary are copies of each other, copies, symmetrical. The term is a little misleading, but you have to recognize it's symmetrical. So these are the same, basically the same entity. They have to have precisely the same interpretation for ellipsis, for any operation. They could be copies, like if I say John saw John, then these two are repetitions. If you look at the generation of the sentence, you had the same formal object, but they were generated independently, and they have nothing to do with each other. This one might as well have been Bill, let's say. Okay. That distinction between copy and repetition is a tricky one. There's an interesting paper by Chris Collins and Eric Grote, which goes through, it's in Lingbuzz, I think. I don't think they published it, which goes through a lot of problems in trying to distinguish copies from repetitions. Okay, I think we can cut through all those problems in a non-trivial way, and again, I'm going to leave it as an exercise for you to work it out. But if we appeal to a very general principle, which seems overwhelmingly true, looks false in some cases, but in that kind of situation, it's reasonable to assume that if we understood enough, it would always be true. The principle that's sometimes called duality of semantics. What it comes down to saying is that argument structure, theta theory in particular, is determined by pure compositionality. So in fact, the strongest conceptual reason, I think, for Dominique's predicate internal subject hypothesis is that the subject gets a theta role. Dominique and Hilda have a lot of other arguments for it, but the basic conceptual argument, I think, is gets a theta role. So therefore, it ought to be determined in the general VP system. Okay. And in fact, anything that gets a theta role ought to be in this system. What about things that are out? And that includes functional categories, like they have an argument structure, but they're going to be determined by just essentially by external merge. What about internal merge? Well, that's always yielding things which have no independent interpretation. So internal merge is sort of determining aspects of semantics which have to do with discourse, with information structure, and so on, not argument structure. That looks like a very sharp distinction. And if we accept it, then it follows that when at the phase level, when interpretation is trying to determine what's a copy and what's a repetition, it has a big, can stand on a pretty high ladder. If something's in a non-theta position, it's a copy. If it's in a theta position, it's a repetition, okay? That cuts very sharply. Now, it does leave possible cases of ambiguity. If you think through the possible cases, there are some that seem not to be determined by this. But here I'll just give you a thesis and ask you to prove it in your spare time. It turns out, I think, that there is a kind of a conspiracy of other principles that solves the ambiguities. The things that seem to matter are Vergniaud's abstract case theory, which makes distinctions that you don't see sometimes in the morphology. And that turns out to be quite important. Another is Rizzi's left periphery theory, which assumes that there are actual positions that, like topic, focus, and so on, that a raised element moves to, okay? And third, connected with this, labeling theory, which tells you when those movements are legitimate, when they give you a real interpretation, when you have to move on, when you don't have to move on. I think if you put all these together, it probably solves the ambiguity problems. But I'll leave that as another exercise. It's a very interesting question. You might think through one of the tricky cases, which is not easy to deal with, is small clauses. So you might want to think about that. So it has interesting consequences when you try to think how that would work for this. But I'll just leave that as a problem to solve. But if we can solve it this way, then we can solve the copy repetition problem simply by looking at internal merge and external merge. Okay. We'll say that every merge operation yields a copy. Nothing else yields a copy. In the case of external merge, the copies that are yielded disappear under the replace interpretation of merge, so you don't happen to see them. Okay. But with internal merge, they remain. And then this phase level algorithm based on duality of semantics, along with the conspiracy that language is kind enough to provide us with, should resolve the ambiguities of interpretation. That's the general picture. You can think about it and try to fill in the details.
No. I still don't understand this basic AB tree and the BC tree. You know, the two trees you put down right at the start, AB and BC.
Like parallel merge.
Yeah.
Okay, so
I
let's.
don't understand why you seem to say that was ruled out by something.
Yeah, it is. So suppose you have A, B, and C. Okay. And now you copy B to C. The way people draw it is like this, but we're not allowed to draw trees. What you're actually doing is forming a new object, B, C. So now you have two objects, A, B, and B, C. Okay, now you take this one, you make it arbitrarily complex, anything you want. We're allowed to merge this. This is accessible, remember. Okay. It's a copy of that. So you can keep merging it again. You merge it to this. You now have a copy relation here, but it violates every condition. It's back to the initial case. All the cases follow from the simple case. Okay. So parallel merge is out.
What's the part of the definition of merge that forbids the?
That blocks this.
Yeah.
Not adding accessible things. You're adding, if you do this, you're adding this thing, which is accessible, and you're also adding this, which is accessible, and in fact, this, which is accessible. So you're adding three accessible things to the workspace. Actually, this one, these are all new, remember. They're not the ones you started with. They're copies of it. So They're new objects, and they're now accessible. Okay? This one, crucially, because this is the one you've moved, and now you have two copies of it, both of them accessible, okay? Plus the pair, which is accessible. So you're violating resource restriction, which is the crucial condition. Most everything is following from resource restriction, which I think is probably a deep property of organic computation. Same is true of sidewards merge, collapses for the same reason. Notice in duality of semantics, that has consequences that may be objectionable. So for example, it seems to rule out Norbert Hornstein's theory of control, right? Norbert's interesting theory of control relating control to raising raises a controlled element to a new theta position, okay? So that's giving internal merge to a theta position, violating duality of semantics. So here we have a problem. Either Norbert's theory is wrong or duality of semantics isn't properly formulated, okay?
Is this the same reason why sideward movement is ruled out?
Sidewards movement, same reason.
Same reason, okay.
It's even more reasons, because at least this, it does form a new object with more accessibility, but there's also the question about how you connect these two separate things, which is another problem. But at least it has the problem of more accessibility. That one runs across all of the extensions of merge. Okay? You look through them, all of them have this property. Okay? So they all basically reduce to this very simple operation that I had down here somewhere about in the simplest case. That serves as a paradigm for just about everything, if you think it through. Okay? So we're now down to, with various problems hanging around on the side, like what about Hornstein's theory of control? We seem to be converging on exactly what we want. The simplest possible operation, conceptually justified, which gives us exactly the cases that don't yield illegitimate operations and eliminates the cases that do. Well, what about all the problems that are left over? So it takes a across-the-board movement. The parallel merge and multidimensionality give you interesting ways of describing ATB. Notice describing, because none of them are legitimate. But at least you can kind of draw graphs that kind of look as if they're doing something, even though they're not. So what do we want to?
Clarification question.
Yeah.
Is the point, was it, so doing parallel merge or, you know, whatever, similar sideward merge, you want that to be bad due to the constraints imposed by whatever gives us a restriction of resources? There's not enough stuff accessible to do that? The way that we restrict resources is just via phases, I guess, if I understand things right. Does that mean that there's a phasey explanation for the lack?
You can't have any operation. As soon as you look at the operation, if it adds accessibility, it's out. Okay? Because there's a meta condition on linguistic operations, probably on general organic computation, but at least on linguistic operations, which says you can't add resources. When you have an operation, it can create one new accessible object. The object that you've constructed can't construct any others.
Is agree also sensitive to this constraint? Agree as an operation, is it also sensitive
agree
to
has the same property.
So it's also a bit
To generalize it, it holds also for agree and labeling and other things. But the interesting case is merge. Yeah. But none of the operations should add new accessible items. This should be a general property.
Why are you have the two A, B, and B, C. Why are the
What are
B
we
and
talking
C
about?
the same
Parallel
merge case?
Yeah.
So you end up with two element sets, which you A, B, and B, C.
Right.
why do you call them
I understand.
the elements of the BC?
What?
Why do you call those accessible?
Accessible?
Yeah.
There's no reason why they're not accessible. I mean, unless you stipulate somehow that they're not.
Why are they?
I mean, if
Why are
this,
they
if this
accessible?
one was able to move from here, then it's able to move from here. I mean, it's the same structure. Unless you impose some other rule that says I'm not allowed to move. But there's no reason for that. Remember, this is a copy in IM. Copies are always allowed to move. So unless you simply stipulate,
If parallel merge is allowed.
unless you simply stipulate I'm not allowed to move, which gives the game away, then you're not allowed to have the operation because there's no basis for that stipulation. It was originally, notice that it was originally allowed to move. That's the whole point. So therefore, it should still be allowed to move. It's the same structure. Okay?
Both move. Now there are two of them.
Yeah, either one or the other. But, so I don't think there's any way to salvage it. It's just out, like all of them, and late merge even for further reasons. Well, let's go on and take a look at the things that the empirical cases that were described by these illegitimate operations, like say ATB. So what did John buy and read? Let's say. Okay. Well, how do you generate this first of all? Well, it would start with I'll forget the reduce support and all that stuff. Simplify it. What John bought. What? Because remember, we're talking about the internal core language, not the external language. And what John read what. That's the thing that we generate internally. Well, why doesn't that give the interpretation? Standard answer, because the thing that he read might be different than the thing that he bought. So it's not giving it the right interpretation. However, think it through for a second. This is a copy. This is a copy. This, of course, is a copy. This is a copy. What is the property of copies? Okay. The property of copies is they all delete except for the top one. That's a general principle of computation. So like in successive cyclic movement, you delete all the copies. I mean, there are languages where you leave some residue somewhere, but we'll forget about that. Basically, you delete all the copies. That's general computation, okay? So that means that in the externalization, we delete this. Of course, we delete these. Well, notice that that gives you the right form. It gives you the form, what did John buy and read? But does it give you the right interpretation? Well, in fact, it does, because of the principle of stability. Remember this principle. It says in ellipsis or topicalization or anything, in the CI system, you can only delete if you have absolute identity. Otherwise, you just can't delete. Okay? General property of interpretation at CI. Deletion requires perfect identity. But notice that that gives you ATB automatically. Nothing else to say. If you think about parasitic gaps, it essentially works the same way. Think it through. There's actually an interesting paper by Rini Hoiberg. It's not in print, unfortunately, but it's circulating around the internet, which goes through the details of it. But in fact, the basic idea is pretty straightforward. Okay, so ATB in parasitic gaps, you get straight. Notice also you get, in the case of parasitic gaps, it follows that a movement won't yield parasitic gaps. because you don't have the initial WH phrase, which will allow the second one to be a copy. So a parasitic app with a movement would be something like, John ate a sandwich, which book did he file, or something? Doesn't mean anything. Okay. But there's a,
I don't understand. I understood you to be saying that in the case of what did John buy and read, it's the same thing that he bought and read.
has to be, otherwise
Right.
you can't delete it at the CI level.
Right, but we can say things like, what did John buy and Mary
What did he read?
eat?
Yeah, that's fine.
But-
There's nothing wrong with this interpretation. It's just not ATB.
So how do we derive what did John buy, what did John read and Mary eat?
You just decide not to call this a copy. Call this something, call this a repetition. You can always call something a repetition. The book was, John saw John. Repetitions, generate them separately. If you don't say anything, one of the options is ATB. Another option is the other interpretation, which is all you want. And notice that if you use the ATB interpretation, then you're deleting. So if you're giving the ATB interpretation, you're reading it as ATB with the deletion, because the deletion is dependent on the stability.
That part I understood, then I didn't understand a sentence like, what did John,
Buy and what did he read?
no, what did John buy and Mary sell?
Read. That's
Where
fine.
Well, it can be different things.
That's just totally different sentences. What did John buy and Tom went to the store? You can generate that.
But there's no question in the second part.
Yeah, but it just has the interpretation it has.
But isn't what you just said, doesn't it force the meaning that there is a thing that John bought and Mary ate?
If you have two WHs, which are copies by definition because they're in IM non-theta positions. So therefore, there is the option for them to be interpreted as copies, and if they're identical, to delete, which gives you the correlation between the ATB semantic interpretation and the externalization with deletion. You don't have to delete it. You could be saying, what did John buy and what did Tom eat? That's a fine sentence. Just nothing happens.
Can I have a follow-up question on this? So I think if one person asks, what did John buy and Mary read, it's possible to answer that question. John bought a book and Mary read a journal, something like that, no?
Not if it's ATB.
But
It has to be the same thing. That's the point about ATB. If you delete, you can't get the different interpretation.
It just feels like a normal dialogue, and then it would mean that
What-
the first was not an ATB interpretation.
What did John buy and Mary read a book?
No.
What did John buy and Mary read? It's the same thing.
Is it possible to answer it, John bought an apple and Mary read a book?
That's a fine sentence. But there's
As
no
an
W.
answer to the ATB question.
No, either it's ATB or it's two independent constructions. That's what ATB is. Think about it. Otherwise, there wouldn't be any ATB phenomena. Okay?
No, but I think that the facts are,
What?
at least I think that for many people, what did John drink and Mary read is fine as a
Then-
question.
Well, for those people, they don't have ATB. Okay? We're talking about ATB, the phenomenon, right? If somebody says it's not my language, sorry. But we're talking about people who have ATB, which has this interesting property that you delete the things and interpret them identically. That's the whole point of ATB, okay? So we're not going into the question of does somebody have some different language, okay? We're talking about the languages which have a problem to solve, okay? Namely ATB. If you don't have the problem to solve, you don't do multidimensionality either, okay?
But are there speakers who have both?
What?
Have both ATB as the meaning ATB meaning and the one which you're saying is the non-ATB meaning? So what did Mary drink and John buy? For me, that's ambiguous. It could mean that, obviously, for some bizarre reason, Mary drank and John bought the same thing. Or it could be John bought a Cadillac and
Yeah.
Mary drank Pepsi.
I mean, if that's your
I mean, my brain's not
interpretation,
exploding.
then you don't accept the multidimensionality analyses either.
Oh, no, I don't. I mean,
Okay,
but
fine.
But the facts are what they are.
That's fine. I don't care. I mean, if somebody has a different system, we can try to describe that one, but I'm talking about ATB.
All right.
Okay? If you don't have it,
I
fine.
do have it, but I have
No,
also
you
done
don't.
it.
You have something different. You have something that is different from what is described in the ATB literature. Okay? But so then we can talk about that. Yeah.
Yes.
Okay, but I'm trying to say that what is captured by parallel merge in the multidimensionality interpretation, in fact, is yielded automatically with nothing. Okay? Good. Same with parasitic gaps. If you look at parasitic gaps, there's a million different problems about them, and this doesn't address those problems. It's just saying the basis, the very basis for parasitic gaps, we already have without anything, including the fact that they are conditional on WH movement in the first sentence, not A movement. All of that follows right away. Then you get into the morass of problems about different kinds of parasitic gaps, okay? A different kind of question. Yeah.
I'm sorry, one more question. I believe in ATB. It's not the same question. So, do we end up with a system where if you're in a theta position, you can either, if you have two things in theta positions, they are either copies or repetitions, and you get to choose which one?
No, see, that gets back to this conspiracy that I was
So
talking about.
if it's John likes John, then they're repetitions.
What I'm saying, what I'm giving you as an exercise is to show the following, and I think it works, that if you accept duality of semantics, the general principle, and you look at these properties of language, I think you end up resolving the ambiguities, determining what are copies and what are repetitions. That's a claim, okay? It's up to you to falsify it.
So, a movement, no parasitic gaps, but a movement is claimed to show across the board movement. So.
It's okay with the person.
So can
No,
you just,
no, this is just dealing with ATB with WH movement, okay? There's other questions about A movement, yeah, but I'm not talking about this. The main ones are the ones in the multidimensionality.
But the line of reasoning that rejects parasitic gaps with a movement.
Well, you don't get parasitic.
Yeah, that explains why you don't get it with a movement.
You don't get it with A movement because the element in the gap, the WH, the operator in the gap, has nothing to be a copy of. So these two things are just totally independent of one another. It's like John ate a sandwich before reading. Just doesn't mean anything.
But it can do it in the case of across the board. Like, would that also lead us to expect that there's no across the board a movement by the reasoning for
Across
why?
the board, A movement is a different problem. It's not dealt with in the multidimensionality literature of the kind that I'm discussing. Okay, I think it works, but it's basically the same. Okay, it's a fair question. We should look at that. Yeah. Okay. Well, the question of the. Sorry.
I have a clarification question about parasitic gaps. So, in a sentence, what did John read after buying?
What did John read after buying?
What did John read after buying?
That's-
The gap in buying, what is the higher copy of it that you elide?
Well, that
Where
would be
is the
something
higher?
like, what did John read, before what John buying? And the two whats are copies. So you get the same phenomenon. If you want the details, look at Rini's paper, but that's basically the structure. Okay, and it gives you the core properties of parasitic gaps. It leaves lots of questions open about different kinds of them. Okay. Well, let me, any more? Yeah.
Sabine, the question Sabine might have had in mind was for you to comment on a sentence like, what two graves were one friend buried in on Monday and the other friend buried in on Tuesday?
This doesn't go into that. I mean, there are many other questions about interpretation. Anybody who's interested in the kinds of questions that Barry's raising should look at the book, the longest book in the literature with the shortest title. It's called And. And the author is sitting over there. And it gives hundreds of pages of very interesting examples of ways of interpreting conjunction and complex structures based on a kind of a neo-Davidsonian event calculus. And there are tons of problems there that are really interesting to solve. But what we're interested here in is asking, what is the basis in the structures for yielding those interpretations? Barry actually doesn't go into that question in the book. See, I think you tell me if I'm falsifying it, that Barry describes it as fundamentally as a kind of conjunction reduction. But if you think about that formally, it can't mean, I think this is I hope, a friendly amendment to the book. It doesn't mean that you first generate all these huge conjunction things, infinitely many of them for a short sentence, and then get the syntactic structure. It must mean, that's the thing I'm going to get to next, that you have a syntactic structure, and there are some kinds of interpretive rules that we have to figure out that give you this mass of amazing stuff that you find in there, okay? That's the challenge to face, and if the event calculus approach is the correct one, that will yield the event calculus interpretations of the structures that you generate. Is that a fair account? Okay. And unfortunately, Barry tells me he's now working on another book called But. I hate to think about that. Okay. Okay.
So how do we handle copies, not copies, resumption under this?
How do we handle resumption?
How do we?
How do we handle resumption, resumptive pronouns?
We don't in this system. That's something else. A lot of things I'm not talking about. Okay, yeah, it's a fair question, but not talking about it. Not that there's any other way of talking about it, right? It's just that if it exists, we're going to want to have an explanation of it in terms of operations which meet the austere conditions of explanation. That's the general point. Whatever problem you're working on, whatever it may be, phonology, semantics, syntax, morphology, if you want an actual explanation within the context of a program that regards language as part of the natural world, if that's your framework, you're going to have explanations in terms that meet this highly austere condition of learnability and evolvability. And about the only thing we know that meets those conditions is merge. So if we can account for things in those terms, like say ATB and parasitic gaps, we're in business, okay? Otherwise, we have problems. Okay, let me turn to another one which is problematic and is related to what Barry was just raising. I'll skip some stuff to get to it. Well, let me just make one more comment about this. I won't bother spelling it out. You'll notice that this is a sketch. I haven't really formalized it, but you can figure out how to formalize it. When you're left with this definition of merge, well, the simplest one, and the one that I think is principled, then you can reformulate it in the usual style of transitive closure, Phrygian ancestrals, like if you're characterizing the set of integers the standard way of doing it is to say the set of integers includes, say, 1, and is the least set. It's the least set containing 1 and the successor of any member of the set. That's a standard transitive closure ancestral definition. The analog here would be the set of workspaces for a given language is the set, not the least set, the set, we leave out least, which includes the lexicon and merge of any triple, okay? That's the set of workspaces. We don't have to say least because that's already incorporated in resource restriction, okay? Otherwise, you get the standard recursive definition of the set of workspaces. Okay, so it sort of fits the norm. You can work out the details. It's pretty straightforward. Instead of that, let's go to something else. There's pretty good reason to think that in addition to merge, which maybe we've now got in the optimal form, there's probably another operation, at least one other operation. That is asymmetrical merge. There are strictly asymmetrical structures, like, say, young man. Young man, the structure it's a noun phrase. The two elements in young man are inaccessible, right? Like you can't extract this and leave this or the other way around. So we have an asymmetric structure where young is attached to man and the whole result is still basically man, adjuncts essentially. All adjunct structures, I think, require pair merge, which is the next operation to look at. Now, there's a very interesting property of pair merge, which has been a thorn in the side of all generative systems since the 1950s, namely unbounded, unstructured coordination. Okay, so things like young, happy, eager, go to Harvard, et cetera, et cetera. You can have an unbounded, unstructured coordination. This is a real problem. You can't generate it by phrase structure grammar. Even unrestricted rewriting systems, which are universal, don't, in the standard interpretation, don't give you the structures for unbounded, unstructured coordination. Now notice that since they're universal, you can code it, but that's not interesting. They are universal Turing capabilities. You can find a coding for it, but that's not of interest. If you look at the generation by phrase structure grammar, you need an infinite set of rules. Okay? It was thought for a while by George Miller and me, papers back in the 50s, that you could get around this with generalized transformations. But Howard Lasnik had a paper showing that the same problem arises. You'd have to have infinitely many of them. So you can't do it by phrase structure grammar, can't do it by transformations. There's no way of generating it. It's been a big problem all along. But notice there is a way of dealing with it in terms of pair merge, namely super multidimensionality, right? So you have, say, man, and you link to it any number of adjuncts. They're all on different dimensions, right? But there's no limit to the number of dimensions. You can pair merge to the element. Okay, there's no reason to believe that just because blackboards are two-dimensional, so is the mind. You know, it does whatever it does. So it could have any number of possible dimensions attaching to a particular point. And that would give you something like unbounded, unstructured coordination. This can incidentally become extremely complex. Here we get into Barry's type of questions. So for example, one of the conjuncts could be a disjunct. Okay, it could be John is young, angry, either going to Harvard or to go to MIT, so on. So you can have, and the disjunct could also be unbounded. So you can have unbounded, unstructured disjunction inside of unbounded unstructured coordination. And this can yield incredibly complex structures. I leave it to you to give the semantic interpretation of them. But in the nature of the system, you can see that this is possible. Well, instead of trying to, actually it's just the formalism is not very difficult, so I won't go into it, but just take the simplest case and take a look at that. Unstructured, if we can deal with unstructured, unbounded coordination, then the simplest cases of adjuncts are just automatic. They're the case where there's only one element instead of an unbounded sequence of elements. So we will get simple adjuncts if we can handle the unstructured case. So let's take a look at that. That's the essential case. Notice a few properties of it. For one thing, it matters what the order is. So if I say, if the order of the adjuncts is young, angry, that's different from angry, young. The reason is because of something that Jim Macaulay noticed back in the 70s, the word respectively. Okay. So if you think of structures with respectively, then the young, angry man ate the turkey sandwich, and the young, angry men ate the turkey sandwiches and the chicken sandwiches respectively. Okay, the order of the adjuncts determines the nature of the interpretation. So somehow we have the object that we have in unbounded coordination is actually a sequence. Furthermore, it can have iterations. Like you can say John is young, angry, young, tired, and so on. You can iterate them. So basically we have, the problem is we have unbounded coordination or disjunction either, which has a sequential structure with possible repetitions. And that sequence is interpreted both at the CI level and the externalization level. Okay, now this does not tell us that linear order enters into syntactic operations. It just tells us there's some object being constructed which is going to be interpreted in terms of its order and spelled out that way, okay? So we're not crossing the barrier into believing that externalization feeds CI, okay? That's important, even though there's order involved. So what we have to have is something that works sort of like this. If you just think of the general properties, you have to be able to pick out a set of things that are going to be adjuncts. And you have to form from that set a sequence. Let's call it this. Where the elements of the sequence are drawn from the set, okay, but in any possible way. Now, that requires an operator. It's actually an operator that's familiar in logic. It's Hilbert's epsilon operator. In Hilbert's formalization of metamathematics, the core operator that he develops, bases it as this epsilon operator, which says that out of a set you can pick an element. Okay, it's basically and, you know, it's like indefinite articles. So we need an operator like this which tells us that given a set in the generation of an expression, given a set, you pick out a sequence, and then somehow the elements of this sequence link to something. Each of them is going to link to it independently. So if I say young, angry man, the man is both young and angry. Okay, so independently they're going to link to something. So what we're getting out of this is a set which, first of all, it'll have to be identified as either coordination or conjunction or disjunction. Okay, so we have an element here, call it K, which will be plus or minus conjunction. It'll be one or the other. And remember, they can be interspersed, but that's just more formalism. And this sequence will include the pair-merged elements Y1 and some link that it's linking to, all the way up to Yn, and a link that it's linking to. And these links have to be identical all the way through. Like if one of them's a WH phrase, they all have to be WH phrases. If you think about unbounded coordination, you can't stick a question in one of the positions. And of course, you can't have different links. So we have an object that looks like that, and that has to be merged into the general expression, okay? That's the formal problem of dealing with adjunction, okay? I won't bother spelling it out. It raises interesting questions. So for example, one question is, what do you actually link to? So suppose you have coordinated noun phrases, John, Bill, Tom, Mary, the guy I met yesterday, et cetera, et cetera. Each of those things is going to link to something. What is it going to link to? Well, the natural interpretation would be that the link, the individual items here, Y, K, L, if it's a noun phrase, they should all link to whatever is common to noun phrases, okay? Some thing, call it N. Notice here that I'm not using the DP analysis, which I think is a mistake. I won't go into it here. But it seems to me that nominal phrases should be regarded as nouns, not as determiners. Determiners are probably something that hang off the outside. And definiteness is probably a feature of the whole noun phrase. So I'm assuming that Semitic is the universal language, that the determiner is just a feature on the noun phrase which distributes somehow differently in different languages depending on externalization. So you have a feature of the noun phrase, specific, non-specific. You have a structure which is basically N with determiners hanging on somewhere, adjuncts that you don't care about. What is this N? Well, here we get back to something that Hagit suggested years ago, that the basic structure of language is, again, kind of like Proto-Semitic. You have roots which are unspecified as to category, and then you have categorizers that determine what they are. So for example, N and the root probably pair-merged, probably in the lexicon. That's probably the first operation, going back to a paper of yours. The first operation is probably a lexical operation. There are many operations inside the lexicon that involve merge-type operations. One of them is probably categorization. But notice that this N that's determining that this root is a noun can't be the same as this one. Okay, same with verb. The V that's determining that something's a verb has to be distinct from what we usually call V or V star, up at the phase level. Those are just different elements. They shouldn't be confused, I don't think. In fact, these, the ones at the phase level, I think should simply be regarded as phase markers. independent of category. Okay? Category is decided down below, probably in the lexicon. At the phase level, you have something saying, I'm a phase marker. And notice that if you take a look at noun phrases and verb phrases, they have some interesting similarities, some differences, but some similarities. One similarity is that both noun phrases and verb phrases can be either, call it strong or weak, with regard to extraction. So the complex noun phrase constraint, it's well known, is strong for specific noun phrases, but is basically inoperative for non-specific noun phrases. It's the same, sounds like the same distinction as between strong phases and weak phases. So transitive verbal phrases are strong with regard to extraction. You have to move to the edge. Weak ones, you don't have to move to the edge. It looks like the same property as weak noun phrases. So possibly what we have is something like this, going back to classical Greek grammar, philosophy, linguistics didn't distinguish. We have the notions substantive and predicate, which gives us a four-way classification of things that are substantive, non-predicate. Those are the nominal phrases. Substantive, predicative, adjectival phrases, non-substantive plus predicate, the verbal phrases, and then non-either, which is all the junk, prepositional phrases and so on. Some structure like that. And the crucial phase operations seem to be restricted to those that are the sort of perfect elements, pure substantive, pure verbal, okay? With either the strong or weak property. Now, one of the curious distinctions between noun phrases and verb phrases, which has prevented the thinking of noun phrases as phases, is you don't get the normal escape hatch. But I discovered a couple of days ago, thanks to somebody, that Booley has an escape hatch for noun phrases. So that fits in the gap that we were worrying about. So let's say Booley and Proto-Semitic are the core languages, and that would put noun phrases and verb phrases together with the ending the idea of using the same notion for the categorizer and the phase marker. They're probably different notions. Adam, yeah.
I would like to go back to the initial definition of merge, since you mentioned the stuff.
The original definition.
The one you put on the board. The first
pair
merge.
merge. Pair merge or merge.
And you said PQ and the workspace, and this is the stuff I saw.
The original one.
Yeah. If you run the clock backwards to the first merge, the stuff we talked about, and Q then becomes the workspace, right? Because in that definition, Q equals the workspace. There's nothing. The workspace is empty until you put in.
If you start with just two things.
No, you start with
one
nothing,
thing.
Right? Before you start merging, there's a workspace which is empty.
Well, there's no workspace until you put something. Well, the workspace is a set.
Okay, so the workspace is the set PQ in this definition? Because why do you have three elements? This is the confusing part.
The workspace can't have PQ unless they get into the workspace. You merge them. So how do you get them into the workspace?
Well, but okay, so and in this recursive way, Q is the prior workspace, right? So at some point you finish merge and you have a workspace before you start another set of merge, right?
I don't follow. Before you do any merge, you have nothing. You just have a lexicon.
But in order to put P, let's say, and Q even into the workspace has to be prior of P and Q being there.
No, it just means there's the option of creating a certain set, which you can put things in if you want.
Okay. So the set, the workspace is essentially something that comes out of PQ being put together. Yes?
Well, the workspace has nothing in it unless you put something in it.
Okay. And then the question is, so the workspace at some point, this Q though, if you have is Q equals Q, right?
No, only if you've put Q into it.
Yes, so that's the next step, let's say, and you have another merger, which is, let's say, P1, Q1. Then Q1 was the previous workspace.
I don't follow.
Because
If-
Q-
let-
Q
let's
is a
let's
workspace.
imagine that we're just beginning the computation.
Yeah, if you could do
We take P and stick it into the workspace. Now the workspace is the singleton set, including P. Now we put Q in the workspace. Now it has two elements. Then we decide to merge them. We get a new element, set PQ, but not P and Q. There is an interesting empirical question here. How do you start? Okay, and there are various options, and they have lots of consequences. One possibility is that the only thing that goes into the workspace at the beginning is things you've already merged in the lexicon. Okay, so if the first, remember, inside the lexicon, there are constructional operations going on, like the words in the lexicon already have structure. Okay, part of the structure, if Hagit is correct, and I'm assuming she is taking a category like N, V, may be broken down into substitution and predicate, and categorizing a root as one thing or another, an operation inside the lexicon, which is giving you a pair, like the pair V hit, let's say, the verb hit. Then that thing can be put in the workspace. It already has two elements paired. Then you could put something else in the workspace, begin to merge them, put more things in, build up the workspace. So,
the increasing accessibility constraint?
no, it doesn't.
Because you're basically pre-packaging things to make them accessible for merge.
Yes, but you're going to have to, you have to, every operation that you carry out is going to create something. That's what an operation is, create something. Now the resource restriction says don't create too much, create as little as you can, at least the thing that you're forming, but nothing else. Okay? Yes, because notice that when you put in the pair root verb, neither is accessible, because an adjunct structure, that's what I said before, if you take, say, young man, you can't extract young, you can't extract man. Notice, incidentally, that this approach, I mentioned earlier last time that there's a way, I mentioned a paper of Željko Boskovic pointing out a way of putting the adjunct island and coordinate island problems in the same package, making them essentially the same problem, based again on the idea of event calculus, which semantic event calculus, which treats adjunction like coordination. So it kind of unifies the problems. And that happens automatically here. The pair merge structure gives you both the islands of conjunction and the islands of adjunction. Now notice that it leaves the mysteries, just like Željko's paper does. So if you look at, say, the adjunct island effect, which Jim talked about years ago, it has interesting properties. There are some languages where you can't extract the adjunct. There are other languages where you can't extract from the adjunct, okay? And other distinctions of that sort. Those are interesting problems that remain. Furthermore, if you look at adjuncts, they're not uniform. There are some kinds of adjuncts which you can extract from. There are other kinds which you can't extract from. So the notion adjunct is too diffuse. We have to sharpen it further to find different kinds of, probably different kinds of pair merge. Those problems all are sitting out there, more problems to solve. But you begin to get a unification of the problems. the adjunct island, conjunct island effects do reduce to the same structure, this sequence that you pick out by the epsilon operator. Now, as far as the point that you're making, as I understand it, it leaves open some questions about how you get things from the lexicon into the workspace. There are a couple of ways of thinking about this, and they have different consequences. One approach is just to take something in the lexicon, insert it in the workspace, and then go on from there. Another approach is to take something from the lexicon and to merge it with something that's already in the workspace. Okay, that's formally slightly different. It has different consequences when you spell it out. You may need both, you know. Those are questions that you want to resolve, certainly. But I think it's plausible to believe that the whole system of operations begins by just forming categorized roots inside the lexicon, then building up from there. Okay. I don't see a problem with that. I don't see the problem you're raising.
These categorized roots are completely invisible to syntax.
Yes,
because
the
otherwise
categorized root itself is, but not the parts. Like you can't just raise the root and leave the categorizer, or conversely, because they're pair merged. And that's essentially the adjunct island.
Right? They don't have to be just moved. They can be targeted by agree, for instance, or other things. Targeted by agree, for instance, or other things. They're also invisible to any operation, not just move, but there's like other sort of syntactic operations which will look at the root.
That raises other questions. It's not, I mean, here we're talking about accessibility to merge. There are questions you can raise about whether you can have agreement into an adjunct, let's say. That's a different question. Here we're talking about accessibility to merge, okay? Lots of other questions, yeah, okay? Let me just, it's getting kind of late. So I'll mention a couple other things that you might deal with in terms of pair merge. There's lots of interesting questions hanging around that have a potential, I think, pair merge analysis. So let's take one that's been a crazy problem for a long time. There's a strange restriction on extraction from causative type verbs and perception verbs. So if you look at structures like John saw Bill walking down the street, you can passivize this. You can say Bill was seen walking down the street. On the other hand, if this was a bare verb, walk, then you can't do it. You can't say Bill was seen walk down the street. This also holds for the kind of causative type verbs. Verbs like let and make. They don't have the full paradigm, but they have part of it. They have I let John walk down the street, but you can't say John was let walk down the street, okay? Now, there's a long problem in the literature about how to deal with this. The only partial solution I've seen is a paper by Norvin. I don't know if it's in print even, left, okay. There's a paper by Norvin in terms of contiguity analysis, which gives a description of how you could block. Oh, back? Okay. Come back in, I'm insulting you. So the only paper I know that says anything about it is Norvin's paper, which this is the blocking passivization out of perception verbs and causative verbs in terms of contiguity theory, which is an interesting description, but it doesn't cover the whole set of data, because the fact of the matter is you get the same property without extraction. So, for example, in English, these structures are a little bit odd. In other languages, they're normal. But things like were seen last night. 3 men walking down the street. You can't say 3 men were seen. You can't say there were seen last night 3 men walk down the street. Okay? So even without extraction, you get the same property. So it can't be based on extraction. It's got to be based on blocking passivization. Now, if you think about it with the let, make type verbs, you can think of those as being basically causatives. They have essentially a causative structure. And in fact, the verb cause itself is kind of resistant to passivization. So John was caused to leave and that sort of thing. So suppose we think of the let and make as being essentially causative affixes, the kind that show up in many languages. That would mean that they're pair merged with C, probably in the lexicon. Well, that gives a unit that's invisible to the operation of passivization. Okay, it's a pair-merged element which is resistant to whatever we think passivization is, maybe eliminating the case structure. Okay, that would block both the in situ cases and the raising cases. In fact, it's the only way I know of dealing with that. Now, it's natural for let and make, because they are kind of quasi-causative. But there's a very interesting question that goes way back as to why perception verbs should act the way the causative type verbs do. Actually, Jim Higginbotham has an interesting paper on this in the 60s, 70s, 80s, I guess, in which he tries to argue that the complement of the perception type verbs is basically some kind of nominal expression with the ver verb. But maybe that's an avenue to explain it. But at least using the device of pair merge, you have an opening to try to account for this strange phenomenon. I don't see any other way of dealing it. Another kind of case that's quite interesting is head movement. Head movement has always been a terrible problem. It doesn't have any of the right properties. It doesn't fit anywhere in the movement system for all sorts of reasons. There is an approach, an interesting approach by Hisa Kitahara. He has papers on this. In terms of pair merge, I'll just give the simplest case. Take T to C movement. Okay, so you have a structure C, T, V, whatever. And at some point, this moves here. Okay. How does that work? It's one of the cases of head movement. Notice that the thing that's moving is really not T, it's V. Okay. This is an error of the traditional head movement analyses. But the thing here is usually described as a T with a V joined to it by an adjunction operation. But it's actually the other way around. It's a V with a T adjoined to it. One of the reasons the traditional adjunction operations just don't give you the right result. There are many reasons. What Hisa suggests is that when you get to this point, you've created this object, you have a C, and then the next operation is to form CT. Okay? Notice that the elements of CT are not accessible because that's a pair-merged adjunction structure. So you've actually enlarged the workspace, but you've only added one. Actually, you haven't even, because you've taken C and added T to it. You've kept the workspace the same size, but you haven't. The only accessible thing you've added is this. So that's permitted by resource restriction. Then the next operation is you've got this thing, and this thing is just to merge them. Okay, when you merge these two things, you get what you wanted, the structure CT with T down here and V. So that gives you a possible way of looking at head movement. Notice it has a problem. It has the same problem as all of the examples back to the original one of resource restriction. What happens if you then make some new thing here, X, you start building it up, it ends up being of the form T, V, and then you decide to merge this to this one. Okay, that's crazy. Doesn't make any sense. But what blocks that? That's the same paradigm we always have. Now, this gets kind of complicated, but I think there's a way out of this problem and I'll leave it to you as something to think about. There's a way out of it by sharpening the notion of restricting computation so that it tells you at each point to add as little as possible to the workspace to still continue. If you think about that, it gives you an interesting direction into perhaps blocking this option. It amounts to a condition that will say you're going to have to merge this one before you create something new. Now, you can't make that too strong, or you won't be able to build up exocentric constructions. So you have to put conditions on it that allow just the right ones to block the wrong ones. I'll leave that as another exercise to the reader. Hisa has a paper which doesn't go into this, it just gives the proposal. Well, there's a lot more that could be said. I think I'll stop at this point. These are the kinds of problems that arise when you try to give a principled approach to the nature of explanation. You get some interesting results, you get a horde of problems. The problems may be presented in an organized form, which is helpful, but we want to go on to try to find real explanations for them. Sometimes you can, as in the case of unifying compositionality and movement, or structure dependence, or the basis for reconstruction. Things like ATB and parasitic gaps, maybe some of these things. But there's a mass of problems out there to try to deal with in a principled fashion. So that's why it's an interesting field.